I'm very glad to be giving this keynote to you today. And I could not travel, and I would have liked to be there in person. However, I'm recording this as a video. My name is Sai Prasad. I'm the Chief Technology Officer for IoT and the Digital Engineering Group at TCS. Today, I'm going to talk about how IoT and AI is accelerating the pace of innovation. What I would do as part of the session is to cover a little bit more details about IoT and how we structure IoT and what are the technologies behind IoT and how it will enable us from a innovation perspective. And then I will cover some of the pointers of what we do at TCS as part of what we call the bringing life to things, which help us and our customers to innovate in doing some of these innovative projects in the space. I will back that up with a couple of case studies and finally conclude on what is the future that's awaiting us. So, if you really go into IoT and look at it from various innovation opportunities, we have divided that typically into 5 layers. The lowermost layer is basically your devices, the sensors, where you actually start getting digital content, the digital information that you're bringing into the system. And from those devices and the digital sensors, you can actually take it into the next layer where we call the network and the communication layer, which helps us to connect all these devices and this sensor information from the digital form to transport it to some place that we call either the cloud or the edge, where you can actually collect and store this information. It's cloud basically when you want to execute something where you have to take large amounts of data from different enterprise systems, or you might have something closer to the equipment, which we call the edge, where you can actually store this information and start processing it further. The layer above that is basically where you have AI and analytics, which actually helps us to understand what is happening from a cognitive perspective, to try and gain some insights and figure out what are the next steps, what is happening to the system, and what we should do from a recommendation perspective. And eventually that gets transported to the higher level, which is then rendered to the end user from a monitoring and an act perspective, where predominantly you can build that on, let us say, on AR VR systems, or mobile devices, on web pages, or even on enterprise applications. And eventually anything that the human does from a decision making, or even if you're trying more from an AI itself to drive autonomy, then the same information on what action needs to be performed transports through these layers eventually to your devices and the actuators and the control systems, so that you can take those actions on those devices. That, in a nutshell, is basically what we define IoT and AI to be. If you go dig a little bit deeper into the technology elements on each layer, each of them gives you those innovations that you can execute at various layers. Now, starting with the lowermost one, where we talk about the devices and the sensors, you can actually have digital devices that you can take from your PLCs, your control systems, your SCADA systems. It could also mean that you can augment information which may not be just coming from sensors. It could be from your cameras, from lidars, things like that. That you can actually collate all this in the digital form. And the network and communication layer, again, you can kind of, to some extent, break it into 2 layers, but sometimes it kind of blurs. What we call the south end of the network, which is basically connecting more closer to the device. So you have like historians, mod buses for PLCs, and your DCS. You can use OPC UA and information of that sort from a network and protocol perspective. And then the other layer is also on the communication side, on how we actually transport this data over the net or over the internet to your data storage. Now, there again, it depends on what are the kind of technology you need to use. In fact, this is, in some sense, what we call as an oxymoron. There are too many standards in this place. So there's LoRa, there is, RFIDs, there is Wi-Fi, there is 5G and 4G communication networks. So what is very important in this area of innovation is to figure out what is the data you need to transport, It depends on the use cases that you're trying to solve and how much of latency you have in transporting some of these elements. So it could be large videos that you need to transport over the net, or it could be just some sensor data that says a yes or no, or a number that you want to actually execute. So depending on where it is and how these devices are located, you need to decide what is the right network communication that you need to perform. And also in some cases, the devices may be, let us say, underneath the ground where you probably don't have physical wiring or connections, and you may not get the regular over the air kind of transport of information. So that forms another layer. Then the cloud and the edge layer, or the data storage layer, again becomes important in terms of figuring out how you need to actually break the information in terms of what you need to do at the cloud versus what you need to do at the edge. Now, here, what happens is, depending on the use cases, sometimes you might need to get a lot of enterprise information. You may not have the information that's directly that you can process at the edge or closer to the device. Then you need to do something at the cloud. But there are certain instances where your customers would be having the information, or the customer's customer would be having that information. Some of that information may not flow all the way into the cloud. Then you might have to do some of the processing on the edge. So depending on where you are actually going to collate and get this information and this insight will be extremely important for you to figure out where you need to break these lines. The AI in the analytics layer is then the core, which actually adds insights and the digital intelligence to the whole system, and where you actually look at how the devices are connected. And for example, if I take for example, a sensor, the sensor would be connected to let's say a process or one or more processes, as well as the sensor is attached to one or more one equipment, and the equipment in turn would be linked to a process. So it becomes like it's not a simple hierarchical structure. It becomes more like a graph network. So you need to understand how this information model is there. You need to look at the ontology of the model and how these various elements are connected. And that gives us the greater insights, because sometimes when you want to take certain cognitive decisions, or AI needs to take certain decisions, you might need to get a collation of all this information, which could also come from let us say maybe an enterprise integration, which may be outside of the system. You need to bring some of those into the analytics layer. And finally, when you render them, you actually bring those IoT applications, and those applications could be on your, let us say, an autonomous car, or you're running something for power utilities or water purifications, or in aerospace, or medical devices. So you basically, or it could even, you could even render these on enterprise applications themselves, maybe the ERP systems or the MES systems or a product lifecycle management system. So you bring those into the application layer, and like I said earlier, it could also be provided on a metaverse perspective. So each of these areas, depending on what is the kind of use case or a problem that you're going to solve, there is enough and more technologies out there. And if you take, for example, the changes that you see from an AI perspective, a lot of things on machine learning, deep learning, and now a lot of things on generative AI. So there's a lot of technologies at each of these spaces. So what is more important right now from an innovation perspective is that you have these technology keys that are already available for you. You need to understand what is the right lock that you have to use to unlock this exponential or the potential that you have. Let me give you one example. So let's say, I mean, just for argument purpose, I'm looking at a bicycle. And so if I have a bicycle and I've designed the bicycle, I'm a manufacturer of the bicycle, I can use these IoT technologies to understand how my customer perceives this product, how my customer is actually using the product. And these data and these insights help me can probably, make a better design of the the bicycle itself. Or I can also look at the manufacturing of this bicycle. So if I'm going to put this into a shop floor and start manufacturing this on a mass scale, I can look at how my equipments are performing. How do I improve the throughput? How do I look at the overall effectiveness, equipment effectiveness of my manufacturing shop floor? I can also add automation to it. I can bring robotics to it. I can look at quality control and some of the process optimizations. But what if I told you that let's say the person who locks a bicycle is not the owner of the bicycle, and the person who unlocked that bicycle is not the person who actually locked it in the first place. It brings the whole concept of the ecosystem, what we call the bike rentals, and that brings a new way of looking at IoT and digital technologies and AI. So with bike rentals, then you can start looking at many of the other things. How are you looking at smart cities? How are you looking at public transport? And for example, if you purchased a bicycle, it might be lying in your garage, but now you're looking at how that same bicycle is now getting used on a day-to-day basis. So you start looking at these kind of technologies which will enable you to solve a business case. So identifying the right use case or identifying the right problem to be solved becomes extremely important. And today those technologies are available. You can explore, you can start innovating, and opening up new areas of where you're trying to solve for not just for yourself as well as for your customers. So that is, in a nutshell, is what we look at from an innovation life cycle. Now, what do we do at TCS? So we have, so this is just probably a waypointer. It may not be like a prescriptive medicine of some sort, but basically what we call this bringing life to things enable us to respond to the physical context by adding the digital intelligence to it. And so that way you can start unlocking that exponential value. Now, what it means is I'm going to actually talk in the next couple of slides on the two ways that we break it. One is there is a business dimension to it, and then there is a technological construct to it. Of course, you can mix both of them, and that actually gives you the ideas to innovate in the space of bringing life to things. Now, from a business dimension perspective, what we see bringing life to things helps us is it becomes either a boundary-less, pervasive, and an experience-rich system for the business. Let me explain. So, if you talk about a boundary-less system, you're talking about an enterprise ecosystem where things are all connected, they're all networked. The decisions are being made, at where you've broken down some of the information silos that were existing earlier, so that you can actually have a better decision making. In the pervasive system, what you're saying is the system is available, it is trustworthy. You have a way to look at the security aspects of the system, as well as you can actually build some of the optimizations and certain decision making that you can have from your overall solution perspective. And in the experience rich area is how do we actually make sure that you have fairly a seamless feedback loop, or is there some way that I can automate this whole operations to bring that completely frictionless and make sure that you have a very efficient path to value and it becomes completely exponential, like that example which I just covered earlier. There's also a technology dimension to this, where what we are saying is the technology, we see them in three layers. The first one is kind of connect in context, where you're able to get all the information in a digital form. And then you can build what we call as a digital thread or a digital twin, where you're able to connect this information and start gaining some cognitive understanding, because you're able to do this information processing once all this information is connected in a digital form. And then you look at some of the predictive aspects of it. How is my system working? Is there a way to have a better operating model, optimize it some on a different scale? So do some of the what if and the if what scenarios, and look at is there a better state in which my system needs to operate. And those decision making will be enabled by AI, by machine learning, deep learning, artificial intelligence, and advanced analytics. Eventually what we want to drive to is to have an autonomous system. And if you want to drive that autonomy, you need to basically make sure that the system is able to learn by itself, it can organize things by itself, it can also heal by itself. So if something is going wrong, it should be able to know how to actually fix it by itself. So these kind of things on bringing that closed loop autonomy is what we need to achieve. So if you were to take these elements, it kind of gives you some waypointers to figure out, what are the kind of use cases that you need to solve in this industry. And of course, all this you have to mix that with core engineering, and that becomes extremely important, because unless you understand the domain of the problem or the customer or the equipment or the system or the process that you're working, it becomes that much more difficult. So in this technology construct, you need to have the process understanding and the engineering understanding as well of these systems. So I'll just give a quick overview of what I do and my group does from the research and innovation perspective. What I have predominantly from my job is there is already TCS research, and TCS research is a very well established research way back in the 80s. And we have about 20 plus research areas, predominantly broken down into four sub elements on what we call as purposeful AI, the digital intelligence, then the cognitive features, and eventually from a sustainability perspective. So, under these systems, we have very focused TCS research, and those research we bring it into our customers in what we call it's kind of an acronym, what we call as an AIC, which is the Agile Innovation Cloud. How do you actually innovate jointly with the customers in an agile mode? So that gives the customer, to unlock these exponential values that we are talking about. We have a very structured way to do this, and we have been doing that for many of the customers worldwide. And we also have, as part of TCS research, something called TCS Space and TCS Spaceports, which are basically some kind of a lab where you can actually bring, our partners and the customers to jointly co-create. That taken into what we call the extended ecosystem is where we we believe that we probably may not have all the expertise. So how do we take expertise? How do you source expertise from emerging areas, emerging technologies, from industry partners, from alliance partners? We call this as the co-innovation network, or coin. Bringing those two together to eventually our customer, where you're able to innovate at scale, is what we do from the IoT R&I perspective. So we have, for example, a lot of work that we do on the industry domains and understanding of different industries, be it in auto, aerospace, power plants, water utilities, retail, life sciences, so on and so forth. We also do some amount of our own research within our unit. In addition to that, we have over 15 plus assets and IPs that we can actually position to the customer so that they can actually accelerate the growth and transformation that we are expecting these customers to have. In addition to that, we also have our own Bringing Life to Things labs. These labs are spread across the world. We have over 9 plus dedicated labs, as well as we work with the corporate Paysport labs. So, roughly from a global footprint perspective, we are spread across the globe. Where what we are trying to do is to provide some kind of a maker space where you're able to create, something to prove your technology, or prove some concepts, POCs, or do some minimum viable products with our customers. We also bring the coin, or the ecosystem that I talked about earlier, where you can bring startups and academia to jointly work in those maker labs. As well as we have some of the state of the art technology in those labs to actually co-create with the customer some of these problems that we are trying to innovate with them. And another thing that also helps us in these kind of things is to bring some of the cross-domain pollination of ideas. So if I've solved a customer problem in certain areas, how do I bring that into another area? So maybe I might have solved something in a life science problem. How do I bring that into retail? Or something that I've done from a retail perspective, I take the logistics and supply chain kind of areas and bring that into a manufacturing side of things. So it helps us to cross-pollinate these ideas, and also talks about because it's spread across the globe, you get a wide variety of customer experience that we work with across the globe. So having said that, I'll talk about I think the next couple of slides I'll talk about how we have solved a couple of case studies in the space. So what I would like to pick up in this particular case is one of the case study that we have done is what we call the boiler calibration and tuning. And this was done actually for a very large original equipment manufacturer of power plants in Japan. So what we have done here is if you take the large utility boilers, when they are installing and commissioning these boilers, you have to undergo a lot of tests. And these tests, like they run about thousands of tests to actually figure out the optimum usage, or the optimum working of that particular boiler. And it also has to cater to certain raw materials that you have to certify. For example, certain components that you have to certify certain chemicals, or certain chemicals that you have to certify. So you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right chemistry, you have to make sure that you have the right experts and they know exactly what happens in this plant. So what we did was we tried to add the intelligence to it using AI, where we built a physics-based model, combine that with artificial intelligence, so that these models can quickly reach the optimum set points. And we were able to reduce their emissions by about 10% and then reduce the unburned carbon by about 1%. And they get about $3 million of savings for every calibration or combustion tuning that they do. What is also notable in this is, just to kind of reiterate, is these Japanese power plants are have they run at the highest thermal efficiency across the globe. So if you take any of the power plant equipment manufacturers across the globe, this is running at the highest thermal efficiency. And to them, we have been able to bring these kind of results. The interesting innovation component on this particular aspect was that we have been doing a lot of work for this OEM in terms of design engineering, in terms of some of the design aspects of their equipment for quite some time. And one of the customer visits, we actually happened to show them what we do in a steel plant. So we have been into doing a lot of things in the steel industry on process optimization and process AI for about 25 to 30 years. So we actually showcased this, and the customer said, "Hey, you know what? Since you know how the coal burning works in a steel plant, probably you can actually look at my boiler and see how we can fix it, or look at this optimization." So you've taken a cross industry pollination example of what we have done for steel and brought it into a power plant. Extending that same story, I've also we have worked with a large semiconductor manufacturing company in the Europe, where we have taken the same concept of calibration and tuning concepts and the math behind it and the AI behind it, and applied that on a very complex semiconductor manufacturing or lithography equipment. So that's the kind of innovation there, where you're able to talk about how do you bring innovation done in one industry across to another industry. I'll switch tracks on to another completely different problem. So the second case study that I would like to cover is on the TCS Autonomous Car. So as you know, from the automobile industry is going through huge shift in terms of, for example, autonomous driving, in terms of electrification, and in terms of the human machine interface, or what we call the digital cockpit. So there's a lot of technology that is continuously changing. So what on the top right corner is actually a picture of one of the cars that we have completely making it autonomous, which works at about level 2, level 3 autonomy. What is interesting about this autonomous car that we're building is we are trying to build it with Indian driving conditions, which is going to be much, much harder than what you would see in a Western world, where you have very specific lane markings, where exactly the road starts and where the footpath starts, or where the road ends, and things like that. So you have very specific information, whereas in the Indian driving conditions, it's extremely difficult. So the algorithms that we use, the kind of technology that we need to have, the kind of sensors that we need to add, all adds a lot of complexity into this process. And below that and underneath that, under a platform perspective, we are using that on a cloud and in a connected system, where we call some of those things on an off-board platform. So it's local compute that happens on the car, as well as some of the compute happens on the cloud, where we are trying to add many of the systems engineering and the safety aspect, because that becomes extremely important. You can also do some of the predictive health maintenance of the some of the very critical equipment that is there on the car. And from a cybersecurity perspective, and when we do some of like what we call over the air updates in terms of the middlewares and things like that, it's very important for us to ensure that these systems have the right security framework, and stop some of the threat vectors that are happening. We have been recognized as a leader in this by the Everest Group. So having said that, and this is, like I said, this is an autonomous car. So in some sense, the human in the loop we're trying to avoid that and making it more a system driven through AI back into how the autonomy needs to work. So both the examples that I've talked about gives you a wide spectrum of what we do in this industry. Now, having said that, so what next? So here, basically, what I would like to cover is the future. And when we look at a future, we are not looking at it as a very simple, single, isolated opportunity. You have to combine things. You need to combine things from a technology perspective. You need to combine things from a business perspective. And through that, you can actually innovate and look at it more from the future. Let me give you a few examples in what we've tried to do in this space. So the technology trends that we've broken that into a like a 2 by 2 matrix, more from how do I organizationally approach this problem, as well as what is the business attractiveness, because you need to look at it both from both the angles, because what is the exponential value you're actually going to deliver in terms of the technology, as well as how ready is the organization to adopt some of these areas. So if you broadly look at it, there could be mainstream technologies, there could be some maybe cutting edge technologies. In fact, one of the things that you see a lot today is generative AI, and how these pre-trained transformers are changing the way you're looking at a problem statement. But the innovation part comes in, how do I combine some of the, like maybe a generative AI along with a digital twin, for example. So if I know that something is going to have a predictive failure, how do I bring the cognitive understanding about what the plant operator needs to do? So we have solutions called the cognitive plant operations advisor, which advises what an operator needs to do if an impending failure needs to happen. These all enable us to digitalize this information, and eventually we can get someday into some of this autonomous way of working. Or you could also look at 5G, and some of the transport of large information of videos, or how do you actually control shop floor through teleoperations, or maybe you can use it in the telemedicine kind of area. So how do you look at transport of large amount of information across the network? So you need to see how these technologies can be collated, combined together, to bring some of the innovative ideas that are there. The other aspect to this also is from a business and a business use case perspective. So for example, you can actually look at the business use case. Also, I've kind of put it on a 2 by 2 matrix to figure out what are the mainstream business use cases and what are some of the leading edge work that we can do. Talking about how do we look at digital avatars, for example, or move towards from industry 4.0 to the industry 5.0, that is more prevalent right now as things are moving on. And also look at some of the sustainability angles that you have from a delivery of anything that you do from a business perspective, how it actually enables your customers to be more sustainable in their business. So, in a nutshell, I would like to summarize by saying that there's a lot of innovation opportunities, there's a lot of technologies out there, and the future is not by looking at one single piece, but how do we combine some of these from a technology and a business perspective to actually innovate for the customers. So, having said that, I would like to conclude, and thank you very much, and hope you have a great conference. Thanks.